All right, let's look at number 12 in the review packet. See diagram to the right. Use the information given to determine which segments must be parallel. So that's what we're doing here. They give us some information, and we have to decide, does that information mean that something over here has to be parallel? And if so, what? Maybe it doesn't make anything parallel. And in fact, that does happen for some of these problems. If you can prove them parallel, give the reason. All right, so let's look at this. Jumping into A. Angle 2 is congruent to angle 11. Here's angle 2. Here's angle 11. I'm not trying to mark them congruent or not congruent. I'm just marking them. Now remember, you have to decide from the get-go what's your transversal and what are your other two lines, the two lines that the transversal crosses. And remember, we can always find the transversal by marking the two vertices and then connecting them. So for this particular question, that's the transversal. And this is X and this is A. But that's the transversal, so it becomes much simpler to figure out what are the two potentially parallel sides. Well, they're the other two sides of angle 2 and angle 11. That's one side, that's the other side. Now, if you kind of turn your head a little bit, or I guess this way, you'll notice what's true about 2 and 11. Well, they're congruent. And they're congruent, and what's their relationship? Hopefully you see their alternate interiors. And when alternate interiors are congruent, then lines are parallel. So this does tell us that this line is parallel to this line. So the correct answer is XB is parallel to WA. And the reason is the converse of the alternate interior angles theorem. And remember, when we prove lines parallel, it's always got to be a converse. Looking at the next one, angle 7 plus angle 14 is 180. All right, where are these? Here is angle 7, and here is angle 14. Again, I'm not marking them congruent. I'm just marking them for purposes of identification. All right, so I'm going to connect the two vertices of the angle. And that identifies the transversal. So the transversal is segment BZ or line BZ. What are the other two sides of angle 7 and 14? Well, there's one, and there's the other. Now, when I look at these now, I say, oh, these are same side interiors, right? They're both on the right side of the transversal. They're both in the interior zone, not up here or down here in the exterior zone. And if same side interiors add up to 180, then I do know that lines are parallel. That's one of the conjectures we studied in class. So that tells me that this line would have to be parallel to this line. Now, some of you might be saying, well, I don't see any points named out here, but this is just an extension of this entire line or this entire segment. So, what I'm really looking for is, any two of the letters down here and any two of the letters down here. So when I look at the answers WZ and AB, this first one is quite good, and that is the correct answer. So, and the reason is the converse of the same side interior angles theorem. And again, it's a converse because we're proving lines parallel. All right, for C and D, C says 12 plus 13 equals 180 degrees. And the question is, does that mean some of these lines have to be parallel? Well, here's 12 and here's 13. Now you look at this and you say, do these add up to 180? And they do, of course, because they are a linear pair. All right, so it's true that these would add up to 180, but the question is, does that mean these lines have to be parallel? And the answer is no. If I look through these, anything that was proving something parallel had a relationship where, one angle had a vertex here and the other angle had a vertex somewhere else, like down here or over here, or maybe over here. We never had a situation where both angles had the same vertex and that made two lines parallel. That's just not anything we've studied. It's not something that's true in geometry. And in fact, you can imagine, stretching out some of these things and making any of these segments not parallel. So right off the bat, once I see that this is a linear pair and not same side interior or same side exterior or alternate interior or corresponding or any of those, I immediately know this is going to be none. You cannot prove lines parallel with a linear pair. It just doesn't work. And I look at the last one, 8 and 14. All right, here's 8. Where's 14? There's 14. And I think to myself, what are these? Well, connect their vertices. There's my transversal. And then I look and say, well, what's the other sides of the angles? There's a side, and there's the other side. And I think to myself, well, gee, is there any way these green lines could be parallel? I mean, it certainly looks like they're going to intersect, but maybe this is one of these weird, oh, I didn't draw it to scale questions Mr. Ruth gives us. So I do want to think about it a little bit more. I say, all right, 8 and 14, what are those? Well, we didn't study these in detail, but those are same side because they're both below the blue line, and they're exterior, right? For this problem, this would be the interior zone. These would be the exterior zones. Same side exteriors, if you think about it, well, you know that same side interiors have to add up to 180, and same side exteriors are just the linear pairs of those. So same side exteriors have to add up to 180. Do these add up to 180? No, they're telling us that these are congruent. So that doesn't help us at all, right? In other words, it doesn't match one of the patterns. In order for things to be parallel, alternate interiors need to be congruent, not add up to 180. Same idea here. If these added up to 180, I might have parallel lines, or I would have parallel lines. But the fact that they're set congruent means the answer here is none.